Good morning, my friend. Today I am going to give information about the isolation of caffeine from tea leaves. How you separate or isolate caffeine from tea leaves. So, caffeine is an alkaloid. We know that. Alkaloids are a class of organic compounds of plant origin which are basic in nature. They possess one or more nitrogen heterocyclic nuclei. Alkaloids are usually colorless, crystalline compounds, insoluble in water but soluble in organic solvent. Most of them are optically active. Chiral center is present and bitter in taste. Caffeine is a common cardiac, respiratory and CNS means central nervous system stimulant. It acts as a diuretic also. It is a white, tasteless substance having a structure closely related to the purine base found in the DNA. Caffeine is a trimethyl derivative of xanthine. If you know the xanthine, then you can make the derivative means trimethyl derivative. What chemical required for the isolations of caffeine from tea leaves is first you have collect the tea leaves, chloroform, 10% lead acetate solution and dilute sulfuric acid. What procedure? So you have to follow this procedure. 50 gram of tea leaves is taken in 1 liter beaker containing 600 milliliter of water and boiled for 20 minutes on a wire gauze. With stirring is added 160 milliliter of 10% lead acetate solution to the hot tea mixture to precipitate the albumin and tannins and filtered. The tea leaves are washed on funnel with 50 milliliter of hot water. 20 milliliter of dilute sulfuric acid is added to the filtrate and the precipitated lead sulfate is filtered off. The filtrate is concentrated to 100 milliliter and then cooled to room temperature. This concentrated liquid is transferred to 500 milliliter separating funnel and 50 milliliter of chloroform is added to it. The funnel is shaken slowly and lower organic layer is drained off. Vigorous shaking is avoided, otherwise formation of emulsion takes place. Extraction with the chloroform is repeated twice, each time using 50 milliliter of the chloroform. The chloroform extract are combined and dried over anhydrous sodium sulfate. The clear chloroform extract is decanted into 250 milliliter round bottom flask and the organic solvent is distilled off on water bath. As the last traces of solvent are distilled off, caffeine crystallizes as an off-white or cream-colored solid. It can be further purified by sublimation or by crystallization, recrystallization from hot water or benzene, whereby needle-shaped crystals are obtained. And record the melting point. The melting point approx 233 to 235 degrees Celsius. What you write in observations, first what you need to do, weight of tea leaves, just imagine or consider x gram, and weight of crude caffeine, y gram. Then you calculate the percentage, means percentage caffeine in tea leaves is equal to y by x multiplied by 100, and then you write the melting point of pure caffeine. Caffeine is insoluble in cold water. Therefore, the aqueous extract has to be kept at boiling temperature throughout the experiment. Chloroform is highly toxic, so should be handled with care. Color reactions means what? You have to take a few milligram of caffeine in a porcelain dish is added 3 to 5 drops of nitric acid and mixture is evaporated to dryness. Then add 2 to 3 drops of liquor ammonia is added to the dried mixture, whereby a purple color develops. Then you have to make the derivative to conform caffeine. For that purpose, you have to take the 300 milligram of caffeine and 225 milligram of salicylic acid are dissolved in 50 milliliter of benzene in a 100 milliliter conical flask. The flask is heated on water bath until benzene begins to boil. Petroleum ether is added just as much to create cloudiness. The flask is cooled in ice bath and the crystals of caffeine salicylate collected, and then you record their melting point, and this caffeine salicylate melting point is 137 degrees Celsius. For this way you have to perform the isolations of caffeine from tea leaves, and this is very good practicals at bachelor level of chemistry. So thanks for watching my video. If you like, then subscribe it. Thank you very much.